So now let's talk about the magnetic force on a charged particle in a magnetic field. So magnetic force on a charged particle in a magnetic field. You see, when you have a charged particle, let's say like an electron, in a magnetic field, that charged body, like the electron, experiences a magnetic force, which is equivalent to F is equal to, is given by F is equal to qVB sine theta. Now, how exactly scientists came about this is what I'm not clear about, but of course you can let me know probably in the comments. Where F is the magnetic force on the body, on the charged particle, V is the velocity with which the particle is moving in the Earth's, in the magnetic field. We have Q. Q is the charge on the body. The charge on the body, and of course it's measured in coulomb, which is C for short. And then we have B, which is of course magnetic flux density. We've talked about it before, which is the number of magnetic lines of force passing through an area. And of course, sine theta is the angle the particle is moving relative to the magnetic field. Theta is the angle at which the particle is moving relative to the magnetic field. Now, where you can observe this phenomenon is a very good example of a place where you can observe this phenomenon is in maybe in Large Hadron Colliders, where you'll have to accelerate a subatomic particle, either a proton or an electron, so you can smash them together and then study the particles, the fundamental particles in it. So we have to do all of that using subjecting them to a strong magnetic field, you know. Now, this equation here, equation 1, shows that for there to be a magnetic force on a charged body, that body definitely has to have a velocity, which means if you have a charged particle stationary in a magnetic field, it won't experience any magnetic force. That's because V will be 0. And if V is 0, that means it doesn't matter the values of all these other quantities here, the force will definitely be 0. And then another factor again would be the angle to which, or the angle at which the particle is traveling relative to the magnetic field. If the particle is traveling in parallel, if it's traveling parallel to the magnetic field, that means theta will be 0. And that means it doesn't matter how fast it's moving, what the magnetic flux density is, or what amount of charge it's carrying, then the force will definitely be 0. You see, and the force will be maximum if the particle is moving perpendicular to the magnetic field. You see, that's when the force will be maximum. So of course you can use now this expression here, the expression VB sine theta is also the same thing as V cross theta. Now this is not multiplication, sorry, cross B. This is not multiplication, it's called cross product in further mass. Cross product of the velocity and the magnetic flux density. These two quantities are vector quantities. So we can do what we call the cross product between the two. So if this is true, so this one is equation 2, here's equation 1. Putting this equation 2 in equation 1, we know that the force, magnetic force on a charged body in a magnetic field is also given by Q bracket V cross B. Any one of them is fine. So you either use this one or this one depending on what's given to you in the question.